Okay. Good morning, everyone, and welcome, or good afternoon, or good evening, depending where in the world you are. Welcome to our 10th ELISA workshop. And what we're going to be doing today is going through what's happening in the ELISA project, and just we're breaking the session up into a little bit of an organizational overview initially, and then talking a bit about the project, talking about how the day is going to be structured, the next 2 days are structured, and then Shuah's going to take over and talk a bit more, give you a bit of orientation on the project. So this session is meant as an orientation, so you can understand the context of some of the other discussions and have some of the further information about what's going to be coming up. For the most part, everything is in the event, and you should be able to logging in through the event, which I think most of you are at this point. And if you've got questions, certainly by all means, put them in the chat or turn on your camera and start talking and let us know you want to talk to us. That's kind of how we sort of run this thing, just to get as interactive as possible since we're not in person. So let me go forward then, and let's talk a little bit about the organizational side of things. So as Evie has pasted in the note, this is an official this is an official event, and like all of the ELISA project meetings, we have to work under an antitrust and guidelines to make sure that we do not cause issues. And we've got our meeting agenda pretty much laid out, and be aware that there may be competitors on these calls, and so be careful in terms of what you're if you're referring to something that might be sensitive or something like that. But this is our standard antitrust policy, and if you've got any questions, there's a link here at the bottom to read it, and we have a firm of lawyers that helps the Linux Foundation deal with these sorts of things. The other thing, I guess, to basically, as an organizational, is we have a code of conduct, and we expect all participants to be professional. Basically, be nice to each other. If you disagree with someone, do it nicely. But by all means, if you don't understand something, please ask questions too. If you've got more questions about the code of conduct, the link is here. And thank you, Evie, she's now put it in the chat, so you can follow it along there. And since we're working in a virtual workshop, we have a bit of a culture that seems to have emerged to be reasonably successful for us. If you want to ask a question of the presenters, just turn your camera on, or else put something in the chat if you're not comfortable with your camera being on. And then, the presenter will look for that and keep an eye on that. And when there's a good break, we'll take the question and read the question back out and then answer. But you can also, everyone in this event has the ability to turn their camera on and unmute themselves. So if you want to ask a question too, again, turn the camera on, wait for someone to acknowledge you, and then you can go ahead and ask a question. We can have a good discussion. As a courtesy to others, keep yourself muted unless you're actually presenting or talking, because sometimes there's background noise that could be a little bit distracting. We have Evie and Bridget on to help us manage this event this time, and they'll mute people if there's some background noise that starts to creep in, but just be conscious of that. And if you're presenting and it's being quiet, or you're not enjoying it, just like I said, you can come in and go out and leave. All the sessions are being recorded. All the presenters have agreed that this could be possible. And we ask you, since we've got a lot of commercial organizations here, not to make sales pitches as part of this. And if you've got any suggestions on how we can improve these types of workshops going forward, by all means, put them in the feedback. Each session has the ability in the schedule to give a feedback rating. And so if you're in there participating, you've come in through the session. After the session's over, give a feedback in there, and and there'll be a survey at the end of this event. They'll be mailed out to the participants so you can feedback. But we are interested in trying to improve these and make these more effective for a virtual audience in particular. So any guidance you can give us is very much appreciated. Everything in this workshop is being shared under the CC BY International Creative Commons Attribution Forum, and which means you're free to share it and you're free to adapt it as long as you give credit. And so, just so that you understand, if there's something that you want to be sharing with someone else, this is the rules for that. And then once we go into the sessions today, well, right now we're in this welcome session, in the strategy session. And then we'll be having today with most of the existing working groups giving sort of a 30-minute update from each of these working groups. So directly after this, the OSEP group, or Open Source Engineering Process group, will be giving its updates. And so Paul Albertella from CoThink is the lead for that, and he'll be presenting. Then we have the Safety Architecture Working Group, and Gabrielle Leoni is going to be, who's been leading that, is going to be presenting. Following that, we have one of our newer working groups, the Systems Working Group, and so Philip Amann from Bosch is going to be bringing everyone up to date as to what's been happening in that group. We'll have a bit of a break just so that everyone, can stand up, walk around, get blood flowing, etc. after that. And then following, we'll be talking about whatever the automotive working group is. So they're one of our use case working groups, and they're looking at a specific application and then looking at the implications for safety in that context. The other use case working group is a medical devices working group, and I'll basically be working with the medical devices team that's there. I'll be sort of sharing what we're doing with you guys on that one. And then there'll be we've got a new working group proposal to talk about today, and this is for aerospace. And so Stephen's going to be presenting what they're going to be aiming for and a general call for participants. And so if you're at all interested in this, or you know someone's interested in this, please, join in on that session in particular. Then tomorrow, we've got one more working group we couldn't quite fit into today. And so Alana is going to be talking about the Linux features in safety critical systems, that working group tomorrow. But amongst all of that, we'll also be having, useful techniques. We've got some other sort of presentations from other community members. So how we can qualify Linux distro for ASLB from Red Hat. The kernel tracing. Shefali's been an intern for us this summer, and she's been working with Shuah on intern tracing. So if you for kernel tracing, and so if you're interested in learning more about how to start setting up a whole tracing infrastructure to work with kernel, I'd encourage you to talk with that one. And then the generation of the static diagrams for architecture-specific images. Alessandro and Maurizio are going to be talking about some of the work they're doing there. Then Alana's going to talk about what's happening on the Linux features. And then we've got Christoph from Aptiv and Lisa talking about the AutoSAR adaptive applications in Rust. So that's an area that there's a lot of people are interested in, so hopefully you find that useful. Oops, sorry. And then after that, we have the analysis of eBPF, which is a very popular technology in the safety use case, followed by using the memory access error detection and for safety argumentation, since there's a lot of materials there. And then trusted execution inside secure enclaves. These are sort of the schedule of the topics we'll be going forward through today and tomorrow. So the schedules are up, and hopefully you can find sessions you're interested in, and we welcome your participation. And with that, I will turn it over to Shuah to walk us through the project orientation.
Thank you, Kate. Welcome, everybody. I'm Kernel Maintainer and Linux Fellow at the Linux Foundation. I also serve as the TSC chair for ELISA. Let's talk a little bit about safety, Linux and safety critical systems. Assessing safety, you really have to understand the system itself. Once you understand the system and what components make up of that system, then you will be able to clearly understand which areas will need more work, identify and need more work in terms of needing more work to be able to evaluate safety sufficiently. It also requires that based on your system, selecting Linux components that would serve your product, right? Yeah, you'll pick those components and features as well. Once you have the components and features set, then you will go into evaluating. You will be ready to, you'll at least have a set of components and features that you need to focus on evaluating safety. And also you have to understand the context on how Linux is used in your system. For example, if you have a watchdog timer, for example, or a memory, you want a specific feature in memory management. Those are all the details you need to worry about. And then the system, what kind of inputs are going into the system, what kind of device drivers would be necessary to implement your product and then drive it. So the challenge here is, first of all, the first challenge is selecting the components and features. And the second challenge is going into evaluating, and how do you go about evaluating the components within that system, and also identifying gaps. So at ELISA Project, we have taken on the challenge to make it easier for companies to build and certify Linux-based safety critical systems. And so let's ELISA mission statement. What are we all about? We are defining and maintaining a common set of elements, processes, and tools that can be incorporated into specific Linux-based safety critical systems amenable to safety certification. What does that really mean? What does it really mean is we do not have visibility into the products themselves. We do not know what components go into those products. So what we are doing is we take a generic telltale use cases. We'll get into that a little bit. Use cases and look at those and say, hey, these are the components that would support this particular telltale. And we look at those and we define processes, a common set of elements and processes and tools necessary to evaluate safety on that particular telltale, for example. So you can read about the technical strategy in the white paper. That's link is here down below. And then this is what we continue to, we have a mission, and we have higher level the technical strategy. We keep improvising or evolving that strategy as a new use cases come in, new challenges come at us. Okay, so let's talk a little bit about understanding the limits. So I alluded to a little bit the challenges we have in terms of evaluating safety and then identifying the gaps. Let's look a little bit into that. So what are the limits as well? Limits in our approach, or limits in generally we will face. We cannot engineer a system to be safe. We cannot ensure that you know how to apply the described processes and methods. We cannot create out-of-tree Linux. ELISA is not about creating out-of-tree Linux kernel for safety critical applications. Also keep in mind that continuous process improvement argument, meaning Linux, as you probably already know, Linux kernel releases are time-based. That means that releases come out once every 6 to 10 weeks. We are currently, our current release is 6.0. We are just, RC4 just came out this Sunday. So the next RC will come in next Sunday, and then every Sunday we get RC and until we have 6.0 release. What that really means is that you have changes going in, and some of these fixes that go into the mainline end up in the stable kernels. So your stable kernel is getting better, fixing bugs. Stable kernels only take fixes that go into the mainline, so that in that respect, you have a scope is limited. However, it's changing. So if you have a safety argument today that you have verified, you might have to look at that in a week's time or 2 weeks' time, depending on however you want to evaluate that. So you have to keep that in mind, that you are dealing with a continuously changing code base potentially. The Linux kernel community has its own development processes. We have our own development process and how we review, pack, and accept changes and fixes and so on. So it is a challenge, not just for ELISA community, for anybody that is basing their products on the Linux kernel, not just safety critical applications, any other product for that matter, including distros to phones to anything else that we can think of, to keep up with the changes, keep up with the development process and safety analysis, to keep moving the safety analysis. When you have changes, how do you re-verify? Don't have all the answers though. However, this is something we are going to provide a path forward with processes, and we are providing a home for like-minded people so that we can discuss the challenges each one of us faces, and then we come up with a process, a solution for that. So you can join us, and we have our mailing list. You can participate in community meetings, and we have working groups meet every week, once a week, and then TSC meets once in 2 weeks, and contribute to the documentation, get involved in the working groups, and collaborate at workshops like you're doing now. And so we continue to collaborate and figure out all these challenges that we are looking at. And you can also find project resources on the ELISA GitHub. And then you can look at working group sites and take a look at those GitHub locations and issues. We document issues. And let me see. Yes, our Git is, our master Git is, of course, Linux kernel Git, and there is documentation processes. You can refer to that. So we hope to, as we develop our processes, and we hope to upstream them and have them finally located in the Linux kernel. Okay, any questions at this point? Okay, let's go to the next slide. We'll go into technical strategy a little bit, and then also working groups. We'll look more into the working groups. ELISA deliverables. I talked about this a little bit. Our deliverables. Is there a question? Sorry, I'm getting some audio. We're good. Okay. All right. ELISA deliverables. What are our deliverables? We develop a qualitative analysis for automotive medical use case, like I talked about use cases. We take those use cases, telltale use cases, and then use that as a way for a reference for us to be able to come up with the resources. And for system integrators, we look at use those telltales and say what would be useful to evaluate the components, identify important components and that need a continuous regression, for example. or focus on for safety. And we analyze those and how to use these processes and resources, ELISA resources, to analyze quantitatively and qualitatively on their systems. So that's so we will be coming up with processes how to first of all discover subsystems, and then once you discover the subsystems, what are the resources and tools you can use to continuously and for safety analysis, and then after that continuously looking at that as changes happen in the kernel. So this is like 3-point method to say discovering, identifying, and then making sure that your safety argument still continues to stay solid as the code base keeps moving. Our hope is that system integrators use ELISA deliverables to analyze their systems. That's the end goal of this. Okay, so our working groups, I'll get a little bit into I'll show you the working group on the next slide. Working groups collaborate in developing qualitative analysis for the automotive and medical use cases, and we are going to be adding more use cases as our members bring them in and interest based on the community interests. Next slide, Kate. Oh, okay, you're already on the next slide. Sorry. No, I mean, can you go back to the previous slide? Thank you. So, okay, so as we are seeing here, we have an automotive use case and medical use case, and we evaluate those two in that context, and then we feed our findings into the safety architecture working group and open source engineering process working group, and then Linux features. So we all of these working groups are very closely tied and coupled. We work to collaborate for good reasons and to collaborate, effective collaboration. Open source engineering process working group looks at, let's get to the next slide, Kit, so we can talk to them. So so that's our working group picture. We'll get back to that, and then all of these working groups collaborate together, and then we come to the deliverables. All right. So what does technical steering steering committee is all about? The TSC is the technical governance, heart and soul of the project. The TSC we have TSC voting members, the working group leads, and community members that we have contributed significantly to ELISA. And then what do we do there? We meet once in 2 weeks, and we also collaborate on the mailing list. It's not just in the meetings. And our activities are defining technical strategy and deliverables, and coordinating linkage between working groups, establishing community and contribution norms. How do we go about publishing? What kind of reviews does it take for us to say publish a process? What kind of after we publish on the GitHub, how do we take reviews and feedbacks and so on? And coordinating linkage between working groups. At times we look at a working group and we say, it might be for a focus, it might be better for us to have split that working group into 2, for example, and focus on different objectives and coming together. So we make all of those kinds of decisions at the TSC. And it's a open forum for technical community, so anybody is welcome to participate, and you can subscribe to the mailing list. And there is we meet twice a month, and we meet Wednesdays European time. So working groups in action, and automotive, safety architecture working group. Let's talk a little bit about safety architecture working group. So determining critical Linux subsystems and components in supporting safety functions. We define associated safety requirements and architectural assumptions to deliver analysis for safety critical integration. What does that really mean? Let's see how these goals transform into our actions, the activities in there. And we definition analysis of kernel requirements derived from domain working group, currently the telltale. So automotive working group says, okay, so these are the requirements for our telltale. Similarly, medical working group is looking at medical use case. And when both of those working groups come in and say, hey, these are our requirements, how do we investigate these based for these requirements? How do we investigate freedom from interference analysis for these between user space processes, as well as the between kernel elements and different different elements. So for example, you have an automotive use case, take that example. If you take that example, you have critical components that have to be, that pretty much always on. That means they have to take precedence over infotainment, for example. So how do we evaluate interference in those two cases between them, for example? So that, how do we make sure? Okay. So it looks like we have 5 minutes left. Let me go through. So that's what safety architecture working group does. And then we have open source engineering process. And we here in this working group, we identify processes and techniques to apply safety engineering principles for systems incorporating Linux. Creating a framework to describe common approach to using Linux in safety applications. And provide common definitions and consistent working practices for all ELISA working groups. So developing a methodology and identifying and documenting these requirements. We have to document these requirements so that they can be used by others. Next slide, Kate. And in the Linux feature for safety critical systems, we are identifying the kernel components, and we dive into kernel features and their potential value to support safety goals. So we are looking at, for example, say we're looking at memory management, fault handling, kernel configurations and settings. What are the crucial kernel configurations that we have to enable, and options we have to enable, features we have to enable to achieve a particular goal of say freedom from interference and making sure the communication works between different components and so on. So for this knowledge, so that's another working group. And then we have tools and code improvement working group. This is where when we identify certain gaps, we'll go, okay, so do we have the right kind of documentation? Do we have documentation in the kernel that supports this finding or identifying gaps in the documentation in various areas? So this working group is focusing on that. In addition to that, this working group, we continuously does code checker and sysscholar fuzzing the kernel code base to make sure that contributing also to the process of kernel development. So we'll be part of that kernel development as we identify gaps. Next slide. Medical devices working group. This is similar. This second use case that we are looking at, automotive and medical devices. We develop best practices, analyze systems, and identify the components of Linux that will be participating in safety analysis. In this case, we are looking at OpenAPS, and we look at OpenAPS as the workload, and we create documentation, results, STP analysis, requirements, and design. So we have been generating a documentation for that. There is a documentation and tooling to support kernel analysis when medical working group is doing, those are the activities. Let me run through a little bit quickly here in the interest of time. Automotive working group, this is the other working group looking at the telltale. And our working group leads, can you switch to the next slide, Kate, I think. And then this is a new working group coming in, systems working group. You can hear all about it in the session tomorrow, I think, if I remember correctly, from Boeing. I'm sorry.
Sorry. Systems will be later today, and then Boeing is the new one later.
Right.
Later today, but systems is different. Yeah.
This systems is coming up later on today. Yeah. Sorry. Thanks, Kate. Next slide. Okay, so I ran through my quick introduction, and then please attend all of the working group sessions. Open source engineering working group is coming up. Safety architecture working group and systems is coming up. And then also we have medical and automotive. And then later on, call for ELISA or aerospace working group. That's coming up later on today as well. Okay, so tomorrow we have kernel tracing and so on. So don't miss any of those if you can, and learn more about ELISA and join us, our community. Thank you very much.
Thank you very much, and looking forward to seeing you in other sessions.